Hi everyone, I'm Seung Ha. Today I'd like to talk to you about something that really changed the way modern aircraft work. The electrical system of Boeing 787 Dreamliner. It's an aircraft that brought a lot of innovation, especially in how it uses electricity instead of traditional systems. So in the next few minutes, I will walk you through how the B787 electrical system works, why it's different, and why it matters. The 787 is often called a more electric aircraft. That's because many systems that used to rely on bleed air or hydraulics are now electrically powered. Things like air conditioning, de-icing, even starting the engines. This shift helps reduce weight, improve fuel efficiency, and make the aircraft easier to maintain. It's also made of over 50% composite materials, which means it's lighter than traditional aircraft. As a result, it uses about 25% less fuel compared to older models like 767. Passengers also benefit. The cabin has bigger windows, better pressurization, and higher humidity, so it's more comfortable for long flights too. These are the photos of Boeing 787 Dreamliners. One of the biggest changes in the 787 is that it completely eliminates bleed air. That's the hot, high pressure air taken from the engines in traditional aircraft. Instead, everything is electric. The air is supply, the anti-ice systems, even engine start. But this also means the aircraft needs a lot more power. Around 90% of the total power goes just to supplying cabin air, and about 8% is used for anti-icing. So, to support this new architecture, Boeing had to design a much more powerful electric system. Now, let's talk about power. Power equals voltage times current. So, if you increase voltage, you can reduce the current. And that means thinner wires, less heat, and overall less weight. The 787 uses 235 volts AC, that's much higher than the 115 volts used in traditional systems. Thanks to better insulation and the use of composite materials, Boeing was able to safely use this higher voltage setup. And because of this, they cut down the total wiring by about 20 miles compared to the 767, and that's a lot of saved weight. This is Boeing 787 electrical system diagram. I attached this as a reference and I will go over in details on the next slide. Compared to the 777, the 787 has 4 times more electrical capacity, about 1.5 megawatts. That's a high jump. It uses different voltage depending on the system. 235 volts for high power systems like anti-icing and air conditioning. 115 volts for standard cabin and avionics systems, and 28 volts DC for essential backup systems. This mix allows each part of the aircraft to get exactly the power it needs without wasting energy. A lot of electricity. Here are some examples what electrical systems control. Please pause the video to see the list. One of the coolest parts of the system is the starter generator. It does two jobs. First, it acts as a starter to spin the engine during startup. Then once the engine is running, it becomes a generator to supply power to the aircraft. This design means you don't need a traditional bleed air system or IDGs. It makes the aircraft simpler and more efficient. The aircraft has 6 generators in total, 2 on each engine and 2 on the APU. Each engine generator produces 250 kilovolts amperes and the APU provides 225 each. This generator produces variable frequency AC power, which is then sent through power distribution units and routed to different systems. Things like the flight controls computers, lights, de-icing, and air conditioning. The system manages power automatically depending on the load required. Of course, safety is critical. The 787's electrical system has a lot of redundancy. According to the Boeing 787 electrical system website, even if 5 out of the 6 generators fail, the aircraft can still fly safely for over 5 hours using just one engine and one generator. And if all generators fail, no problem. The APU or RAT can kick in to provide backup power, and batteries are also available for critical systems. If the main generator stops working, the auxiliary power unit generator will automatically come online if available. If the APU isn't available either, the ram air turbine or RAT will deploy. It uses the airflow outside the aircraft to spin and generate electricity. And if things get really bad, onboard batteries can power sensor systems like avionics and instruments long enough for the pilots to land safely. I'd like to go over a little bit more detail for the ram air turbine. The ram air turbine RET is a small device with blades that spin in the wind. It provides enough power to operate the flight controls computers and basic cockpit displays. However, it cannot support everything. For example, it won't power the cabin air system, but it gives pilots what they need to control and land the aircraft in an emergency. And on the slides, I'll attach some photos of RAT for your reference. And for the batteries, the 787 also has two main batteries, one for the aircraft system and one for the auxiliary power units. They are lithium-ion batteries designed to provide quick and reliable power. In a total power loss situation, these batteries can support critical systems like communication, navigation, and giving the pilots precious times to act. For pilots, handling electrical issues is all about staying calm and using the tools available. The basic rule is aviate, navigate, communicate. First fly the plane, then figure out where you're going, then talk to ATC. However, in case of Boeing 787, cabin pressure system ran by its electrical system, so pilots for Boeing 787 should also consider the cabin pressure system. If power to the cabin pressurization system is lost, they will need to descend quickly. Fortunately, modern displays and automation help the pilots respond quickly and follow procedures safely. EICAS, the engine indicating and crew alerting system, is central to this. If there's an electrical issue, it will show messages telling the crew what's going on and what to do. In critical cases, a master warning light will also come on, grabbing the crew's attention right away. This helps them troubleshoot the issue while focusing on flying safely. So to wrap things up, the 787's electrical system is a big step forward in aviation. By removing bleed air and moving to electric systems, Boeing made the aircraft lighter, more efficient, and easier to maintain. Its backup systems and redundancy also make it one of the safest planes flying today. Thanks a lot for watching, and I hope this helped you understand how the Dreamliner electrical system is really changing the future of flight. Thank you. And lastly, this is the work sources that I used for this presentation. Thank you again.